Yo, what's up, guys? Welcome back. Episode 43. Doing a little early morning video here. It's about 10 a.m. Yeah, a little early morning video. Let me just grab. I need to find my the problem set. Hang on, guys. Yeah. Here we go. Okay. Oh, okay. Yeah, a little early morning programming. We're gonna do a few problems today. Our usual 2 or 3 or whatever, depending on our time. But yeah, we're gonna check out our Pokemon of the day today. I believe it is I don't know if there's an evolution after Golbat. Maybe there isn't. Nope. We got an Oddish today. Another classic Pokemon. Let's take a look at the sound. Who's that Pokemon? Oddish Cry. Blah. Blah, 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 blah. I don't know, something like that. Yeah, that's our Oddish for today. Yeah, we're gonna keep going. So I think we finished all the linked list problems. Yeah. I think we might finish our last stack problem. I think we have one more left. Yep. We got the asteroid collision down here. So we're given an array of asteroids of integers representing asteroids in a row. The indices of the asteroids in the array represent their relative position in space. For each asteroid, the absolute value represents its size, and the sign represents its direction, meaning positive right, meaning negative left. For each asteroid, the absolute value represents its size, and the sign represents its direction, meaning positive meaning right, negative meaning left. Each asteroid moves at the same speed. Find out the state of the asteroids after the collisions. After all collisions. If 2 asteroids meet, the smaller one will explode. If both are the same, both will explode. 2 asteroids moving in the same direction will never meet. Wow, this is actually a very tough problem. I think there's a lot going on in this question. So we got 5 here. I think 5 will collide with negative 5 because this is going right, this is going left. So the 10 and negative 5 resulting in 10. Five and 10 never collide. Oh wait, is it 10 and negative 5 that collide? Two asteroids meet, the smaller one will explode. So 10 and negative 5 collide, so that turns into 5. Okay. These both will explode. And here, we finished with 10 and 2, right? No. The 2 and negative 5 resulting in negative 5. The smaller one explodes though, I thought. Oh no, it's the absolute value. Right, so 2 explodes. Resulting in negative 5. The 10 and negative 5 resulting in 10. Okay. This is definitely a stack problem. Let's think about this. So let's get up our paint. Got one from yesterday over here. Okay, so we go to our stack here. All right. So I guess we can almost go from right to left, but are we going to add the value or are we going to add the indice? Let's take a look. So I guess we got 5 in this case. We got 10. We got -5, right? So let's say we add 5 to our stack, right? So we add 5. Since our stack is empty, we add 5. And we look at our next value. Well, we have to look at the sign. So somehow we got to figure out a way to look at the sign. Well, if 5 and 10 are the same, they're both positive, then we can add it here. Yeah, asterisk I does not equal 0, it cannot be 0. Okay. So we add 10, right? Then we want to compare for our next value here at the top of the stack. Well, the top of the stack is 10. And next value is a negative, then these two are going to collide. But the -5 one explodes, right? The -5 one explodes. So therefore we don't even add -5 to our list, we keep 10, right? Two and -5 collide, resulting in -5. Thing is, this is the one that we got to think about here. So alright, so okay, so let's take a look here. We have 10, -2, sorry, no, 10, 2, -5. We go the same way, we add 10 to our stack. There's nothing in our stack, so we add 10, right? If we have a 2, and 2 are both greater than 0, so they're both going in the same direction. So first we really got to check what the sign is. But the absolute value represents the size. So, okay, we add 2, they're going in the same direction, so we can add to the stack, right? However, when we look at our next value, -5, it's going in a different direction. But the absolute value of this one is greater, so that means that this one's going to explode. So we would pop from the stack, add -5. Right? But then somehow we need a way to compare these two. That's the thing. And how can we do that? Well, no, actually, I guess what we can do, right, is that, yeah, we pop from the stack, but then maybe we can have a while loop that checks every value, right? That goes through and checks every value with this one. Because technically this could be like -20, right? And if it is, we can go through and just pop everything, you know? So we got to have some sort of while loop that keeps iterating to check all the values in the stack and keeps popping them if they're bigger, because then they explode. So I think that's the way that you have to approach the problem. To put that in code, I think that's the tough part. I have to respond to my friend really quick. Okay, so we got our stack here, right? We want to go through, well, for I in nums, right? We don't need access to our indices, I don't think. Let's do for val in nums, right? Well, if stack is empty, right? I guess if not stack, we just want to append our value, right? So append stack.append val, right? Else if stack and stack minus 1 is greater stack minus 1 is greater than 0, right? So this is if top of stack is positive and val is positive and val is greater than 0, right? Then we can append stack.append, right? We need another else if. Well, if our stack is not empty and our stack minus 1 is less than 0 and our value is less than 0 as well, then we can append to the stack, right? But actually, maybe we got to check for each one, right? So maybe this here needs to be in a while loop. So while our stack, we can check, well, while our stack has something in it, then we can stay in this loop, right? So get rid of this. Well, what do we want to check in our stack? Well, we want to check if stack minus 1 and val is greater than 0. Okay, if stack minus 1 is greater than 0 and val is greater than 0, and all we want to do is we just want to append, right? Stack.append, we want to append our value, right? While stack. Want to append, and then we want to break, right? So we break, we continue. Wait, hang on. Trying to think here, well, is this going to be an infinite while loop? I guess I'm trying to think, like, well, if not stack, right? Then we just want to append. But if we have something in our stack, then we want to check each number in the stack. But what if there's a value here? They're going to keep popping these values, right? So trying to think here. Well, let's check our things here. So we'll check, well, if top of stack, let's do it one by one small section by. If the top of our stack is positive and our val is negative, right? So our val is less than 0. Then we want to check, well, if the absolute value of stack minus 1 is greater than the absolute value of val, then we just want to break, right? If not, if the stack minus 1, if the top of the stack is greater than the absolute value, so if the top of our stack is greater than the absolute value, then we don't even want to append, right? But if not, then we want to stack our pop. We want to stack our pop, right? Okay. Then we want to check the other one. Well, if the absolute value of our stack minus 1 is less than 0, and sorry, not the absolute value, if stack minus 1 is less than 0 and the value is less than 0 as well, so the value is greater than 0, and we want to check, well, if the absolute value of stack minus 1 is greater than the absolute value of val, then we just want to continue, right? Else, we want to pop in the stack, right? So we got our two. Oh, this needs to be here. Oops. Okay, so we want, this is our next case, right? The top of our stack is negative, and our val is positive. And we want to do this, right? So now we got to think about the case where they are the same, right? So we want to check the case. Check the case, they are the same, right? So here we can check, well, if the stack minus 1 is greater than 0 and the val is greater than 0, then they're the same, right? And we can wrap this in an OR. Well, OR stack minus 1 is less than 0 and the val is less than 0, then we can just append to our stack, right? Or should this need to be outside? That's the thing. I think this might need to be outside our while. Because here in this while, we're just... I think this might need to be outside. Well, let's independently check.
As I said earlier, what I want is to just...
There's 1,000.
Okay, and here we're going to return our stack. Let's take a look at this. Dumps, the name nums is not defined. Oh, whoops, I meant asteroids. Asteroids. Oh, this is wrong. We need to check. If not stack. Maybe can we put this in our loop here? But then we're going to go through this loop. We're going to loop through our stack. This isn't going to work. This won't work here. We want this while just to loop through, right, and pop from the stack, right? Stack. If here, right? But you want to do like, well, if stack, right? Then we want to check this. We want to append. Maybe we need an else here. There's no way this is working either, bro. There's an indentation error, dude. What is that? On line 24. It's meant to be continues. Else here. Stack up pop. I think we're on the right track though, like man, I was close. go back to what we were at before. We want to do for Valen asteroids, right? We want to our while, like we want to go straight into our while. So we want to do while stack. While stack, right? Then we want to check these here, right? Stack -1 is greater than 0 and val is less than 0, then a collision occurs. Isn't it? While stack and stack -1 is greater than 0 and val is less than 0. Isn't there a way where val is less, like here? This goes at the end. Oh, we want to check here, right? Well, this is what we want to check. We want to check, well, if abs stack -1 is greater than abs val, then the top of the stack survives, so we break. Right? Abs stack -1 is equal. Is equal, we forgot to check this, is equal to as val, then they pop each other, right? So then we just pop from the stack as well, and then we break, and we break. So you just pop from the stack, right? And you want to do, well, if it's empty, right, then we just append. And we want to return our stack. We were close, man. Like, I had the right thinking, but I just couldn't execute it. Like, val in asteroids, while stack and stack -1 is greater than 0, and val is less than 0, the collision occurs. I'm so confused here, bro. Like, oh. Even an array of asteroids, this is an asteroid, the array represents the relative position in space. For each asteroid, the absolute value represents its size, and the sign represents its direction. Positive meaning right, negative meaning left. Each asteroid moves at the same speed. Find out the state of the asteroids after all the collisions. If two asteroids meet, the smaller one will explode. If both are the same, both will explode. Two asteroids moving in the same direction will never meet. But while stack and stack minus 1 is greater than 0, yeah, and the value is less than 0. So we're going to do here, we're going to see that this is here. Check, well, if the absolute value of the stack is greater than the absolute value, if the absolute value is greater than this one, yeah, then we just break. We don't do anything, right? Stack is empty, so we append 10. They're the same while stack, else we append, right? We append 2. And we see that -5 while stack, and stack minus 1 is greater than 0, and val is less than 0, so we see that. We do, well, if the absolute value of stack minus 1 is greater than the absolute value, this one in this case it isn't, no, then we append. Okay, else we pop, right? So we pop 2. Right, so then we compare, well, -5 to 10. We see that this is bigger, so we just break and not add it, so then we return 10. It's a much more concise way. I was thinking too much about all the different cases, like, it's way more simple than that, like. I like this problem. This is a good problem. This one actually wasn't as bad as I thought it was, but you know, we needed a little bit of help to get there in the end, but you know, I think I had the relative idea on how to use the stack. Like, I think when I was explaining it here in this paint, like, I explained the process of how to do it. And we needed the while loop, we needed whatever, so we'll take that. Take a look at the solutions. Returning stars from a string. What is this? I solved this one. September 26th. Let's take a look at this one. It's been a while since I solved this one. I think I probably solved that one in Java. It was that long ago. You're given a string S which contains a star, right? In one operation, you can choose a star in S, remove the closest non-star character to its left, as well as remove the star itself, return the string after all the stars being removed. So either you can choose a star in S. In one operation, you can choose a star in S, remove the closest non-star character to its left, as well as remove the star itself. There's stack? Yeah. Another stack problem. I think it's like kind of a similar approach to, I mean, it was in the discussion of the other one, but you can use a stack here and we can do, well, while, sorry, for val in S, we can check, well, while our stack is, while stack is not empty, and I guess in this case, well, if our char is a star, right? So if our char here is a star, then we just have to pop from T and pop from T and break and move to the next value, right? All stack and stack minus 1 is greater than sorry, stack minus 1 equal to val and val is equal to a star, or is it like this? I don't know. And all stack and stack minus 1 is alpha and val is equal to, we just wanna stack the pop and then we want to break, right? Else I think we just wanna append, stack dot append. And we want to return our stack. Append. Oh. We want dot join stack. I think we got it there. I don't know. Maybe we just got that in 2 seconds, right? Damn, bro, I'm a dog, bro. What's the study plan, bro? Start the study plan. This is from Leetcode 75. Total progress 1 through 75. What is this? He's coding interview with 75 questions. Dude, it's giving me 1 out of 75, bro. What's going on here? Weekly ranking, solve 75 problems. Jeez, bro. I think I've done a lot of these. Binary tree DFS. Yeah, the 2 pointers, array string, 2 pointers, sliding window, prefix sum. Hash map / set. Haven't done like any of these ones down here, binary search a little bit. I just haven't got to any of these bit manipulation ones. It's like, bro. Tough, bro. I have to get to, well, soon. I mean, eventually we'll be looking through heaps and other stuff. I just want to take it slow, you know, make sure I really understanding everything, and yeah. So we got our stack. So I think we finished our